My name is Paul Anderson, and I work for Dynatrace. I'm an information architect there. And today we're going to talk about synchronizing clusters in Fusion environments, specifically trying to leverage CDCR and streaming expressions to accommodate this goal. Dynatrace, in case you're interested and don't know who we are a software intelligence platform based primarily on application performance monitoring. And if you look at our pretty little Gartner chart there, you see us way up in the upper right hand of the magic quadrant. So our stuff's good, you want to use it. But enough of the marketing, let's get on to what we're going to talk about. So first things first, we're going to talk about why you want to use multiple clusters for search. We're going to talk about what data needs to be synchronized between those clusters. We're going to talk about how to sync that data between clusters. And finally, how to monitor those sync operations and make sure that the synchronizations are taking place as you want. And it's kind of hopeful that we'll have some time for Q&A at all as a function of how fast I can get through this. So, how many people here have multiple clusters in their search environment? Okay, about a little more than half. Very cool. So I'll zip through this because you already know why you're doing multiple clusters, but step one is multiple clusters are going to enhance performance. On the left is an AppDex map of the world for 3 months of our search environment with one cluster in the US. There's a lot of orange and red in there. That's not that great. Then we added a second cluster in Europe. A lot more green, a lot more yellow, very little red. Though now that I'm looking at this, I'm thinking maybe a Singapore cluster is in our future. The other reason is we need to support failover. We have 2 clusters right now, one in Europe and one in the US. And just back on August 30th, some of you may know about this because Reddit took a hit. The US East 1 data center for AWS had a power outage. But being AWS, they had a whole fleet of generators that popped in to back up the data center until one of them blew up, taking out a portion of the data center, including our search front end. Well, the good news is we have a traffic policy in place that automatically rerouted to the opposing cluster, and there was not one customer session that was impacted. There was no weeping and gnashing of teeth or support calls or Slack messages from my friends saying, what the hell? So that's why we want clusters. What needs to be synced between the clusters? First, the obvious stuff. You have to replicate the infrastructure. You're going to have to replicate your installed applications on that infrastructure. You need to import your Fusion application. Now, having said that, note that there are going to be some cluster-specific differences in your Fusion app. So from a source control standpoint, you're going to need to keep track of that. They aren't identical. At the very minimum, the ZK host strings are going to be different for the different clusters. So with the obvious stuff out of the way, what about the actual collection data itself? Well, obviously you have to replicate the search index. Surely you can just independently crawl in each cluster. A lot of people do it that way. But indexing is expensive. It takes up cycles. It reduces your response time if you're also taking queries on those same nodes. So we did a recent test and found that the only search requests that weren't as snappy as we wanted them to be were all happening during crawls. So if you don't have to crawl in the remote cluster, you're better off. You can't, what I'm getting at is that syncing the index itself would be preferable, and we'll talk about CDCR in a minute. The signal data itself, you want to synchronize as well. The click signals, the response signals, you want to get those. Well, some of you maybe wonder, does anybody wonder why we want to sync signals? You want to know why? Well, you're going to find out. So why do we need to do that? Well, the signals are going to contribute to relevance boosting. If you don't sync, yes, you could have some preference-based differences, say cultural differences and preferences that are going to skew your search results. You could even describe that as a feature. But you're also powering re-ranking algorithms. Your signals can serve as ground truth for learning to rank models. If those get skewed off too different, you're going to have differences in your results. So if you want consistent results across clusters, you really need to sync the signals. And I'm going to give you a personal boosting example. We use this at Dynatrace so that the customers get, we're leveraging their search history is what I'm saying. So here's a customer, and he lives in the US, which means that most of his search traffic is going to the US cluster. Consequently, all his search history is in the US cluster. And then he flies to Europe and does a search that he did 3 days ago. Where is his search history? It's gone. That item that was number 1 on his list is now number 8. What happened? This is why we didn't sync the search history. Another possible example is what we just talked about. You have a failure, and the traffic policy comes in and says, oh, wait, no, now you're hitting the European cluster. Again, your search history isn't there. You need to synchronize it to get it over there. So here's our search sync to-do list. We need to do the main document collection. We need to do signals, but we're getting them from both directions. Got to be bidirectional. Scary monsters. Anything else? That's a question for you guys. Anything else you can think of that we might need to sync? I just off the top of my head, I was thinking maybe cache of user permission data. It's transient, it's short-lived, because you want to refresh it every day. Probably not a big advantage there. System logs, oh, just say no, you don't want to do that. Aggregated signal data. We tried that. The problem with syncing aggregated signal data is the aggregations touch a bunch of documents, not just new incoming signals being added to things, a lot of historical documents. So you're expecting, hey, we got 10 new signals, but it affects 20,000 aggregated documents. That's bad, and you have to sync a lot more then. So we found that syncing the raw signals was actually better. Bueller, any other ideas? What you might need to sync? I couldn't really come up with much of anything else, so we're going to concentrate on the main search index and the signals. So we got 3 options, and I'm not really in love with any of them. One is using Solr's cross data center replication. Anybody here use CDCR? Nobody oh, we got a couple use CDCR. I want to talk to you about your success rate. In essence, you're for unidirect, oh, I'm sorry, use? Oh, well, there you go. You're going to love some of the rest of this. In essence, for a unidirectional CDCR, you're configuring one cluster as the source, a remote cluster is the target, and you're pushing changes. The good news is that all the changes in the source cluster get replicated. Adds, updates, deletes. It's very handy, and the promise is quite compelling. A second thing that we can do is you set up separate crawl schedules. A lot of people fall back to this. You do each call twice. That's not ideal, but you're not really supposed to crawl. I mean, it'd be ideal if you didn't crawl in both clusters at the same time, so you probably want to stagger that schedule. That way, if the crawl operation is, making response times heavy in Europe, well, maybe the latency in your, in your traffic policy is going to direct traffic to the US in that case. And yes, there is going to be more chances for minor differences in the index because of the offset schedule, but that's probably acceptable. So what about streaming expressions? Because, hey, it's in the title of this presentation. Surely that must factor in. The problem with streaming expressions is they don't handle deletions. You can handle updates because the ID is going to be the same when it gets written. You can handle new pages, documents, obviously, but you can't handle deletion, so it's not ideal. Consequently, we don't suggest streaming expressions for the search index. So which one to pick? Isn't CDCR the best option? It can be, but it has issues. We used, I have to confess, unidirectional CDCR for our main search index for over a year. It was brilliant, it was fantastic, it saved us effort. And then we introduced a couple of new data sources that had different data update strategies, where we deleted the docs first and then recrawled the same docs via a single fast REST call. And CDR stopped working, and we have not been able to get it to work since. So, suggestion, if you're interested in it, try CDCR. Try it in a staging environment. Do not put it into production right away. Now, this means you're going to need multiple clusters in your staging environment to properly test it. But put it under load. See what it does. If it works, great. But be prepared to have a crawl schedule in the remote cluster in place, because it is problematic, it is fragile, and in a lot of cases, it's going to fall down. So, search index recommendation, make the crawl schedules for your clusters, even if you plan to do CDCR first. Avoid the crawl overlap, as I said, for best performance. Put a policy, if you have traffic policies available at your disposal, put one in place based on latency and back-end health. And if your CDCR implementation fails, whether it's day one or a year in, go enable your crawl jobs and crawl in the remote cluster for coverage. I realize that's a little anticlimactic, but the state of CDCR right now, that's the best we can do, and we're going to talk about that a little bit more later in this presentation. So now we get to the sexier part of the presentation. How do you sync the signals? Well, that depends on your version of Fusion. So who here is still running Fusion 3? Yeah, I know, we were just in your presentation. So a couple of people still are. We were up until about May of this year. So here's what happened with signals, or what could happen with multiple clusters in Fusion 3. You've got your two TwigKit, AppKit, whatever we're calling it this week, in their different clusters. And we had some other web properties that were consuming search via API calls. So in the US, the signals go right into the index signals ingest pipeline. That's a Fusion default. But you could configure the EU cluster to send its signals to the US. Now check out how this plays out. Oh, and by the way, the web properties are also harnessed to send to the US specifically. So the signals ingest pipeline dumps its signals into the US collection. Now, unidirectional CDCR to the rescue, pushes it to the EU collection, after which both clusters can run their own aggregations, and suddenly everything went dark. All right, very well. I'm not sure exactly what happened there. Hopefully it doesn't happen again. So anyway, in a nutshell, the signal aggregations fire independently in each cluster. You end up with similar, not exact, but very, very similar data in the aggregations collection both ways. Now, we tried, and I alluded to this earlier, unidirectional CDCR of the aggregation collection, but the impact was way too high. It was way too busy, so we felt it was better to do the incremental updates of the signals themselves, and we didn't do that. So some of you are wondering, but didn't he just say CDCR was bad? It is, but signals can, in our signal configuration, that was a simple implementation, and it actually worked fairly well. Because you almost never have an update, you never have a delete, all you're doing is adding. All you're doing is adding when it's a signals collection. And CDCR seemed to be able to handle that. And we actually had that, the signals being replicated longer than the search index before it too, unfortunately, did start to fail. So what changes when we're in 4X? Well, wow, everything changes. So now we have AppKit, AppStudio, again, in their respective clusters. And we still have our independent web properties that are also leveraging our search. And in both cases, and this is a difference now, the incoming signals are bound to their local cluster. You can't tell AppKit to send it someplace else. If you enjoyed that feature in 3, get ready to lose it. So we still had the web properties all sending to the US. That was just a convenience factor. We didn't have to upgrade or update them and their implementation. But now you have new inputs. We have the pretty green response signals being generated by the pipeline. That is independent and in each cluster separately. Then the ingest pipeline, of course, is still independently in each cluster, putting the signals into the signals collections. But then you have yet another new player if you're running the session aggregation roll-up job. This is unique in Fusion. Instead of reading from signals and writing to the aggregation collection, it reads from signals and writes back into signals, introducing a third flavor of signal, aside from click and response, and this is the session signal. That runs independently in each cluster. So the challenge then, and in Fusion, in Solr 7, what is it, 7.5? No, 7.2 and later, you have bidirectional CDCR. The temptation is to use bidirectional CDCR to synchronize all those flavors of signals from that single collection back and forth. And as before, let the signals aggregation jobs run independently, populating the aggregation collection. So the dicey part is that thing right in the middle. And the temptation is, hey, this must be a perfect job for bidirectional CDCR. However, the main thing that bidirectional CDCR was designed for is easy failover. Anybody who's implemented CDCR unidirectionally knows you have different changes to your Solr config on the two opposite sides, in the two clusters. So if you want to change what's the source and what's the target, you have to edit your Solr config. The thing that made bidirectional compelling is you put the same configuration in both sides, and then it keeps track on, well, which side is doing the indexing? Where am I getting my changes? And then it'll automatically swap directions when needed. A year ago, at Activate 2018, I had long discussions with Lucidworks and Solr employees, committers, whatever you want to call it. And we came to the conclusion that because the signals are always additive, and because neither cluster is going to create a duplicate ID, it should work, indexing from both directions. So we tried it, and it doesn't. What invariably happens is the source and target swap logic is not very fault tolerant. It wants to see nothing but indexing on one side and then a hard switch to nothing but indexing on the other side. When you're going back and forth and back and forth and back and forth, it loses its mind. In a test environment, low traffic, it actually worked pretty well. In a production environment, it quietly went away. And the response you get is it replicates in one direction only, and in the target, you're accumulating T-log files like a banshee. Watch your disk space. So the overall verdict on CDCR as a whole, again, simple unidirectional implementations can work, but it's very fragile. It fails for unexplained reasons. It doesn't support Solr authentication or authorization. Anybody using those plugins? The Solr authorization, you're using authorization? Yeah. Basic auth? Okay, well, you're going to have challenges. We should talk after this. We should talk after this talk. And even Solr committers here at this conference will tell you straight out, it's got issues. So I can't recommend it right now. I know you guys are using it, yeah?
Yeah, I'm trying to
Yeah.
Seeing the input outputs on the target cluster, those problems, those that you
Yes, similar. In essence, what happens is, you know, the replication stops at some point. You may turn it on and it works for a while, and then it could be a day, a week, a month, and then it just stops.
This is one thing we saw from the others that it seems to be working, because you can see this with the parameters of status and
Mm-hmm.
but it doesn't really work on the key logs, and there is still nothing.
Yeah, yeah.
And another thing that we saw that seems to be common is the autocommit. It just commits it to the target cluster if you do this manually. So autocommit doesn't really
I had bumped into that exact problem.
This is another thing that you might encounter there. So CDCR is really, I don't know how to even do this.
Well, again, right now, I would just say no. Now, last two words, for now. There is hope. A band of Lucidworks developers and a couple of Solr committers. A band. It's like I'm talking about Robin Hood's Merry Men. They want to champion fixes for CDCR. You'll hear rumblings of a CDCR 2.0, you know, that sort of thing. But they need your help. So if you have friends who are Solr committers, let them know. Even if you think you're going to want to use this someday, tell them you need CDCR to be righteous, and you need it fixed, because it has issues. So what do? Streaming expressions to the rescue. So what are streaming expressions? Gospel according to the Solr doc. I'll read it right off the screen. Streaming expressions are a suite of functions that can be combined to perform many different parallel commuting tasks. Ladies and gentlemen, that's the tip of the iceberg. There is so much functionality in here, so many different combinations of sources and decorators. It is really exciting. And if you were here last year, there was 15 talks on streaming expressions. So anyway, anybody using them already? Anybody using streaming expressions already? Not one hand? Oh, well, this is going to be interesting for you guys. So what do we need? We need a streaming expression to push signals from the US cluster to the EU cluster. And then we need another to push signals from the EU cluster back to the US cluster. So what we're actually going to leverage is, and we're getting into some Solr terminology. If you look at your doc, this will make a little more sense. We're going to have a topic stream source, which we're going to nest inside an update decorator, which we're going to nest inside a Daemon decorator. And yes, I'm going to talk a lot more about what all this means. Before we get to configuring that topic source, we need to do a couple of things. The topic is a stream source, and it's going to be a source of data. In this case, it's a query into the signals collection. Give me some signals. We only want to query the signals that originated in the US. Note that I'm talking about the US copy to the EU for the rest of this. You would duplicate this for the opposite direction. So we're going to create another stream expression send EU to the US. I just said that. We don't want the new signals to be passed back and forth and back and forth and back and forth. We only want them to go in one direction. So what we're going to do is in Fusion, in the signal ingest pipeline, we are going to create a new field. When the signal comes in, we're going to add a cluster field, and we're going to set it to the name of that cluster. I used AWS region names, US East 1 and EU West 1, over here on the left. And that's a chunk of the field mapping stage where we actually set that for the US cluster. Now, again, from a source control standpoint, this is one of your differences between your Fusion app between clusters. So, I mean, you're going to have to track that. So, another supporting requirement is, remember those session signals I was talking about that get generated from that roll-up aggregation? Well, they go back into the signals collection. They need to be synchronized as well, so they need this cluster association with them. So what we're going to end up doing is, this is the SQL code from the default Fusion 4X roll-up aggregation, and you see the two chunks of red that we've got here. We've added a line to grab the first cluster, because it's using time differences to group together a set of requests. And we're going to grab the first cluster that it finds and use it for the entire session. And then down here on the last line, where we actually write the new aggregated session, or I should say the new session signal back into the signals, we have to add that cluster field. So we're grabbing that in the select and we're writing it back in. So now even our session signals have a cluster definition. We're from the US, we're from the EU, we're from wherever. And again, from a source control standpoint, this actually is global. This isn't a difference between clusters, because this is applying equally to all your clusters. So this is one thing that you can just make the change. You don't have to maintain it separately for clusters. So this is what the topic looks like. And it doesn't look like a very interesting piece of code, but it actually does a fair amount. The first parameter is stream checkpoints. This is the collection where the stream is going to store its progress, because it's only grabbing the latest set of signals from the last execution. This is the checkpoint that lets you do that. We have a collection to query. I'm just going to use my signals, something underscore signals, as is typical in Fusion. And here's that cluster field. Cluster US East 1, that's all we want to select. We're going to return all the fields, and we're going to put an ID on this topic, and that ID will identify the set of checkpoints that get saved as belonging to this specific topic, this specific request. And we'll talk about these in a little bit more detail. So collection to store the checkpoints. You'll need to create this collection, stream checkpoints, before you try to run the expression. It needs to exist. I happen to use a 2-shard single replica collection, but you could easily do a single shard 2 replica. That's up to you. And in this example, the collection, as I said, is stream checkpoints. That's a bit simple. If you're going to do a bunch of topics, you really want to have more descriptive names. This is an actual checkpoint document in that stream checkpoints collection. And we have that ID that I was talking about, that signals topic in bold up above. And it's going to store a checkpoint per each shard. Now I happen to have 2 shards in the signals collection, so I get 2 checkpoints. The version numbers, by the way, always go up. The signals collection, because it's a local request, there's no ZK host string. The cluster US East 1, this is the query that we're going to run against the collection. We made this change to introduce the cluster field to the signals ingest pipeline in the session rollup aggregation. And the fields to return, we want them all. Keep in mind, you don't have to annually exclude the version field. When the streaming expression replicates the signal to the target, the signal is going to have the same ID, but different versions. Okay, within each collection. That's different from CDCR, where the versions actually replicate. So the topic ID, this is again the idea that we're associating with the topic itself. Again, there's the piece of a document, a checkpoint document with the ID identifying the signals topic. So one note about topics in general. There is a note in the Solr doc that says, until Solr bug 8709 is fixed, avoid topics, consider them beta. That's a bit of a lie. It has to do with version numbering and the possibility of a new document being introduced with an older version number and therefore being omitted from the replication. Nobody's been able to make it happen. It's been open for 2 years. Nobody's been able to make it happen, so safely ignore that bug. Nothing to see here. But I'm just saying, if you look at the Solr doc, you're going to, oh my God, he didn't talk about that bug, but yes, I did. So here we're going to configure the update. So this is the upper 3-4 lines here above the gray topic that we just created. So we're going to set the target of the results returned by the topic. What do we want to do with them? Well, we want to send them to the target cluster. So we have the target name. Happens to be the same name that we're using in this cluster. We have a batch size. We have a ZK host string identifying the Zookeeper ensemble in the target. And of course, we have the topic payload that we nest inside it that we just talked about. So again, I'll kind of zip through this because I know I'm going to run out of time. This is the collection that we're going to write to. It must already exist in the target cluster. It won't create it for you. And unlike CDCR, you're not compelled to have the clusters have the exact same shards and replicas. If you need them to be different, you can. It won't affect the streaming expression. Number of documents to send. Signals are small, so you can get away with a pretty good chunk. I used 500 in our production environment, and I like to combine this with the run interval, which we're going to talk about when we talk about the Daemon settings. And I like them to combine to try to cover all the incoming signals in one batch. I just want one batch sent. If there's more than 500 to send, it'll do it in multiple batches. But I'd like to keep it down to one batch. The ZK host string, everybody here knows what ZK host strings are. It's the target string of the Zookeeper ensemble. I show it on multiple lines. You're not going to want to break it up like that. It has to be on one line. Also, port 9983 is what you're going to use for this communication. So if that's not open between your clusters, you need to open that, otherwise it's going to fall down. Now we get to the Daemon, which is the third thing we're wrapping. Notice we have the update and the topic already in the payload here. So the Daemon is a decorator that's going to tell us, this is what's going to update the, this is what's they actually run. It's going to sit in memory as a thread, and it's going to run this as a repeating execution, kind of like a cron job. You give the Daemon an ID, because you can have several of these running. You need to be able to differentiate between them. That run interval that I mentioned, that you combine with the batch size and a terminate setting of whether to keep this thing running or just run it once. And then finally, you've got the update and topic that we already talked about. So the ID of the signals daemon, or the ID that I just called it signals daemon to keep it simple. Down here at the bottom, where we do a request to check the status of the daemon, that's where you're going to see that ID come back. So this is why you want to set an identifiable ID, so you can track whether the daemon is still alive downstream. And if you have multiple daemons, obviously you want a little more descriptive name than what I used. So the run interval, I used, this is in milliseconds, so I'm set for a 10-second interval. So every 10 seconds, it's going to send new signals, and if I configure the batch size correctly, it'll just do one send of up to 500 signals to the remote. If there's more than 500 due, it'll go on, it'll continue to run it until it eats through the 2,000, 5,000, or whatever needs to be done to send. But it's going to do it in 500 document pieces or signal pieces. Terminate. If you set terminate to true, the daemon will load, it'll stay in memory, and it'll run once. Not very useful. If you set it to false, it'll continue to re-execute at the interval that you set by the run interval. So for the purposes of this demonstration, always, always, always set terminate to false. So the entire request, this is how you actually start it. The stream API that you're going to access, pretty simple. You just pass all of that daemon update and topic payload that we just created, all those parameters. You put them in one nice long string and send them with a curl command. What I've done here is you're going to make the request, well, actually I just talked about that, but the collection, which in this case is stream daemon host, is the collection where the daemon is going to be created. So the thread that gets created in memory is going to be attached to that collection in Solr. So the temptation is to use the same collection that you're querying. Why not just use the signals collection? Well, here's the problem. Does anybody here have a signals collection that doesn't have multiple shards? No, they all have multiple shards. When you make the request into Solr and all you give it is a collection name, it's going to randomly pick a replica and attach the daemon to that. And then when you come back later and run the action list request to say, well, how's my daemon doing? It's going to randomly pick a replica. And if it's not the same one that you happened to end up on, it's going to say, I don't know that daemon. What are you talking about? So my suggestion is the better solution, the second item down here, make a single shard, single replica collection. You're not going to put any data in it. All it's going to do is host this thread. And then you can just make a simple request to that collection. It's always going to be available. It's always going to be one replica, one shard. You're never going to have any ambiguity there. And you can see it in the snippet from the cloud there, that stream daemon host. Must be running low on battery. So I usually curate this collection on the same instance as the instance in the cluster where I'm going to be actually running the daemon, and I put this code into a shell script so I can run it from my, this curl command, I put it in a shell script so I can run it from my Jenkins pipeline. So we're running low on time, so I got to speed up. How do we monitor the sync? Checking the search index, I'm going to kind of cut to the chase and say, just get the counts. If you want to be more specific, get the counts per data source. Fusion gives us that nice LW data source S field, and then you can count counts by data source. So if you have differences creeping in, you can figure out where they are and try to track them down. With the signals, you can do the signal counts in each cluster. Keep in mind that with the different timings of the daemons, they're never going to be exactly the same, but they're going to be within, depending on your traffic, 10, 5 signals of one another. And I alluded to this back on this slide, I wrote a shell script that just runs the requests and get these numbers and puts them in a CSV file so I can load it in to some business intelligence software. So this is the API call, and remember, everybody's going to get these slides at some point after the presentation. Notice the name, stream daemon host, and then the stream API, and then action equals list. And that is going to give us a result that looks something like this. Now, what do we have going on here? There's the ID of the signals daemon. Here's some Unix epoch numbers for the start and stop time. Stop time is 0 means the daemon's still running. You have a state, waiting, and timed waiting is what you're generally going to see. And the number of iterations is how many documents have been passed. A state of terminated, this is a terminated response. A state of terminated and a stop time means the daemon has failed for some reason. And we'll talk about responding to this probably pretty quick here. So I'm actually going to skip through this, unfortunately, because of time constraints. They will be in the slide deck and they're pretty self-explanatory, but in essence, when you start up the daemon cold, it's going to set the checkpoints to now and process everything that comes later. If you have existing signals in there, it's not going to process them. Oh, don't frown. We'll get to that in a second. When you do a normal process interval, that means it's been running for a while, it's very similar. It's going to query for the new documents. It's going to send the documents to the target cluster. It's going to update the checkpoints and wait for the next interval, which when you restart, I'll cut to the chase, this is exactly the same thing. So we'll talk about the bootstrap in a minute. Where I'm going with this is if the daemon terminates, just restart it. That's all you have to do. The checkpoints are persistent. They even survive Solr restarts. So you restart the daemon, it's going to go right back to where it left off and continue copying. Now, if it's been off for a day because you missed that it terminated, yeah, that first copy is going to take a little while, but then it'll just keep trundling on its merry pace. So I saw a frown when I said it wouldn't bootstrap. You can do this. You need to set in the topic initial checkpoint equals 0, and you need to go into that signals collection and clear the checkpoints. You can just do a delete operation in that collection. And I'm being told that I've run out of time. Are you going to let me run off into the break time a little bit? Like another 5 minutes?
It's time. We do have other presenters supposed to be here in about 10 minutes to prep for that.
Okay, I will be fast. So, streaming expressions totally rock. Are there any downsides? Yes, it doesn't support the Solr authentication plugin. So when you said you were using it, I'm sorry, this is a bit of a moot point for you. We have an open issue, both in Solr and with Lucidworks, to try to fix that, because we need it, but it's not done yet. Daemon failures, I'm going to skip through this pretty quickly. In essence, they can self-heal, because all you're going to do is restart the daemon. You restart the daemon, the persistent checkpoints allow the updates to continue where you left off. They can self-heal. I have a script that I'm working on, which I was going to show off today. Unfortunately, at 2 a.m. last night, I still didn't have it done. So, in essence, you could have a script that does that request for the action list, looks for a terminated daemon. If it is, just rerun the curl command to start the daemon. It just fires right back up. That's all you need to do. If you want to get nice with it and save these checks to a log file, okay, with a timestamp and oops, terminated, had to restart, that'd be very easy to do. We're going to push it up to S3 in our plan. And that was going to be... The only other thing I was going to go over is this is the 2-cluster scenario. What happens when we go to 3? The temptation is to do this. Don't do that. Don't be that guy. That's a lot of additional moving parts, and there's a much easier way to deal with it, and that is change the request, change the query. So we introduced AP Southwest as a new region, as a new cluster. So that's being written in to the signals because we made those same changes down in the AP Southeast 1 region. So now the old daemon that used to write back to the US East, we give it a new ZK host string to talk to AP Asia Pacific Southeast, and we tell it, well, don't just get EU West, also get from US East. And I see nodding heads, you know where I'm going. You do the same thing in the new daemon you're going to put in AP Southeast. Give me the new ones that appeared in AP Southeast plus the ones that were copied over from EU West. Now you're just one daemon per cluster. You haven't cluttered everything up with 6 that you have to keep track of. So, in a nutshell, until CDCR 2, whatever it's going to be, comes out, it's safest to do crawls for the synchronizing the search index in each individual cluster. When CDCR is righteous, it is the right answer to this. It's just not ready for prime time right now. And for the signals, we're going to use streaming expressions unless you have to have the Solr authentication plugin. And then you're kind of SOL, or you have to come up with another security solution if you have to use the streaming expressions, because the fields in the stream sources and decorators just don't know about authentication yet. I don't know that we have any time for questions, but if anybody had a quick one. Hey, just one.
So is this going to replace Spark for small ETL jobs?
I would argue it's easier to set up. Yeah. You may get more logging opportunities with the Spark job, but we've been running this in prod since May. It's hiccup 5 times, and it's all been Zookeeper connection timeouts. And again, the recovery is, well, restart the damn thing. It's fairly painless. So I really like this solution, and if you want to sync signals, it's kind of the best game in town right now. Any other questions? Yes, sir.
What kind of volume of signals are you dealing with?
The highest volume we've had has been in the thousands in one interval, but admittedly that was in a catch-up mode when it had failed over the weekend and we caught it on Monday. And I didn't notice anything in the way of, you know, inordinate load for more than just a momentary blip. I know with you guys, you've got a boatload of signals coming in every given second, so I think you'd have to play with the interval and the batch size to get it reasonable and reliable. But I strongly suggest that you can make it work. And you had a question?
Yeah. So what do you do for a DR type of scenario?
Excuse me?
What do you do for a DR scenario, disaster recovery scenario? So do you use the same CDCR with streaming expressions to keep the DR sensor in sync?
Yeah, I don't see why it couldn't.
Okay.
I mean, I think that would work.
Okay.
We might want to talk about that offline. Sure. I've gone over. My timekeeper hates me. Everybody, thank you very much.